Okay, come on to the third topic in coordinate geometry basics, and that is to divide a line segment in a given ratio. So I've drawn our diagram here with the points P and Q, and T will be the point of division, and the ratios I've given as K and L. In the completed triangle there, the x-coordinate of S and the x-coordinate of T are the same, and the y-coordinates similarly. So the x-coordinate of T, which I've written down here, will be x1 plus ps, and ps will be x1 plus nk over nk plus nl times x2 minus x1, the difference of the x-coordinates. The reason I've written nk and nl instead of k and l is because obviously those two are not the same, but the ratios are the same. And the lines TS and QR are parallel, so we've just used a basic theorem from geometry saying that transversals crossing two parallel lines will be divided in the same ratio. So moving on from where I've put the star, we've now got x1, so I'm now at this stage, x1 plus k over k plus l, because the ends cancel out, is times x2 minus x1, and I've just written all this as under one common denominator. So I've had to multiply k by x1, which gives me this term, and also l by x1, which gave me that term, and then k times x2 minus k times x1. Now, the k times x1s conveniently cancel out, so that leaves us with lx1 plus kx2 over k plus l, and that completes the bit for the x-coordinate. And the y-coordinate goes through the same sort of way, and that will be ly1 plus ky2 over k plus l. So that's how the easy way gives you a nice easy formula for dividing a line segment in a given ratio. So for example, suppose we have 2 points here, 4 and 5, and 12 and 18. I'll just put this at the top of my head, and we want to divide that in the ratio 2 to 3. Well, we call that point T. The x-coordinate of T will be 3 times 4 plus 2 times 12 divided by 2 plus 3, which comes to 36 over 5. And similarly for the y-coordinate, include that is 7.2. And similarly for the y-coordinate, that will be 5 times 3, or 3 times 5, plus 2 times 18, divided by 2 plus 3. And what does that give us? That gives us 15 plus 36, which is 51 over 5, which is 10.2. So those are the x and y coordinates. Before I just finish that one, we want to just take the special case where k is equal to L. If k equals L, in other words, we've divided the line into a given into two equal parts, okay, then tx, using the tx part, will be Lx1 plus Lx2 over 2L, which will be x1 plus x2 divided by 2, and similarly for the y coordinate ty, it'll be y1 plus y2 divided by 2. So that's to find the midpoint of a line segment. Okay, you just take the average of the coordinates, and that's it.